Dear students, under the lecture series of graph theory, here we have the lecture 2. We are going to learn the types of graphs in this lecture. There are various types of graphs. Few to list out are: here we have simple graph, multigraph, pseudo graph, connected graph, disconnected graph, null graph, complete graph, bipartite graph, complete bipartite graph, regular graph, and cubic graph. So these are the different types of graph that we will be learning in this video lecture. In fact, we have even more types of graphs which we will explore as we proceed to proceed with further lectures. Okay, so now first here we have the simple graph. So what is a simple graph? A simple graph is a graph without loops and multiple edges. That is, if in a graph, if there are no loops and multiple edges, such a graph is known as simple graph. Now for example, we have a graph here. You could see that there are no multiple edges. As well, there are no loops in this graph. So therefore, this is an example for simple graph. Next, we shall move on to multiple graph or multi-graph. Here we have the next graph, that is multi-graph. A graph with more than one line joining same two vertices is called a multi-graph. Now for example, we have, if you see, the vertices V2 and V4 have two edges joining them, that is this as well as this. So these are the multiple lines. So if multiple lines are joining two vertices in a graph, then it is said to be a multi-graph. And very importantly, there will be only multiple lines in this and not loops in such a graph. Then it is known as a multi-graph. Next we have pseudo graph. So what is a pseudo graph? A graph with both loops and multiple edges is called a pseudo graph. So now suppose in a graph there are multiple edges as we have seen here, as well as loops along with it, then such a graph is said to be pseudo graph. So a graph without loop and multiple edges is said to be simple graph. A graph with only multiple edges is said to be multi-graph, and a graph with both loops and multiple edges is said to be a pseudo graph. So here we have the next definition of connected graph. A connected graph is a graph in which there is a path between every pair of vertices. So if you take any pair of, every pair of vertices, there will be a path between them. That is, here we have one example. In this graph, if you see, if you consider V1 and V3, there is a path between V1 and V3. That is, we can travel from V1 to V4 and from V4 to V3. So therefore this is a connected graph. So like that, if you take any pair, we will be able to reach one vertex from the other vertex. So either there will be a direct vertex or there will be a path like this. For example, V2 to V3, you have a path V2 to V4, V4 to V3. Okay, so this is a connected graph. The next definition is disconnected graph. A graph is the disconnected graph if at least one pair of vertices has no path. So now this is as a whole is one graph, but it has two components. Since there is no path between V2 and V5, V3 and V4, V3 and V6, V3 and V5. Similarly, if you see here, there is a path between V1 and V3. But if you take V1 and V5, there is no path. So therefore, this is a disconnected graph. Disconnected graphs can be categorized into components. So this will be known as component 1 and this will be known as component 2. Next we have the definition of a null graph. A null graph, a graph whose edge set is empty, is called a null graph, or it is also known as a totally disconnected graph, which means there will be no edges in that graph. So now if this is a graph where we have only vertices, there is no edges between these vertices. So such a graph is known as a null graph, or it can also be called as totally disconnected graph. Next we have the definition of a complete graph. A complete graph, a graph in which any two distinct vertices are adjacent, is called a complete graph. So if you take a graph and if you take a pair of vertices, those two vertices will be adjacent to one another. So if you take any pair of vertices like that in that graph, it will be adjacent to one another. Such a graph is only known as complete graph. Now here we have an example. Now this here we have a graph with three vertices. So if you take V1 and V2, they are adjacent to one another. V1 and V3 are adjacent to one another. V2 and V3 are adjacent to one another. So this is a complete graph. Now we will consider this graph with four vertices. V1 and V2, V1, V3, V1, V4 all are adjacent. V2, V1, V2, V3, V2, V4. Like that, if you check, all the vertices will be adjacent to one another. So similarly, this is a graph with complete graph with 5 vertices. So if you check, all the vertices will be adjacent to one another. For example, V1 if you take, it is adjacent to V2, V3, V4, V5. Like that, if you check for each vertices, every pair of vertices will be adjacent to one another. And a complete graph with p vertices is represented as Kp. And here if you see, this is a complete graph with 3 vertices. So this graph is K3. This is a complete graph with 4 vertices. So it is K4. And this is a complete graph with 5 vertices, and so it is K5. Next we have the bipartite graph. A graph G is called a bigraph or bipartite graph if the vertex set V, that is the vertex set V of the graph G, can be partitioned into two disjoint subsets V1 and V2 such that every edge of G joins a point of V1 to a point of V2, and this V1 comma V2 is called the bipartition of G. So now if you see a graph G, we will consider, and we will have the vertices V1, V2, V3, V4, V5, V6. All these vertices belong to graph G, but we are bipartition. We are just by these 6 vertices are having are separated as sets capital V1 and these vertices as V2. And we see that the line of V1 joins the line of V2. That is, the set of vertices from V1 joins only the set of vertices from V2. And there will be no line between the vertices of V1 among themselves. Similarly, among the vertices of V2, there will be no edges. So, such a graph is known as a bipartite graph. Next, we have the complete bipartite graph. So, in a bipartite graph, if every edge joins the points of V1 to all the points of V2, then it is called a complete bipartite graph. That is, if you consider any two, that is, the graph G is has a bipartition V1 and V2. Now, in this, we can see that if we consider the vertices of V1, it will be adjacent to every other vertices of V2, the set V2. So, here also these are adjacent as well as these. So, if you have such a graph, it is known as a complete bipartite graph. So, if the vertices of G can be bipartitioned into two sets V1 and V2, and there will be no edges between the vertices of V1 among themselves, similarly V2 among themselves, but you will have edges from V1 to V2, then such a graph is known as bipartite graph. If every vertex of V1 has an edge to every other vertex of V2, then it is known as a complete bipartite graph. The next is a regular graph. If all the vertices of a graph G have the same degree, then G is called a regular graph. Now, if you consider this graph, what is the degree of these vertices? For this vertex, the degree is 2. For this also 2 and this also 2. So, this is a regular graph. So, what is the degree of this vertex? 1, 2. What about this? 2 again. 2, 2. So, this is also a regular graph. Now, if you consider this graph, here you have a vertex which has degree 4. This vertex has degree 3. This has degree 1, 2, 3, 4. And this also has degree 4. And this also has degree 4. So, here we have a point where the degree is not 4. This degree is 3. Okay. Yeah. So, these 2 points are of degree 3 and these 3 points are of degree 4. So, they are not same for this graph. So, therefore, it is not a regular graph. Next, we have the definition of cubic graph. A regular graph of degree 3. So, it should be a regular graph, that is all vertices should have the same degree, and in particular it is of degree 3 It is called a cubic graph. Example is here. If you consider this vertex, the degree is 3. What about this? It is also 3. 1, 2 and 3. So 3, and degree of this vertex is also 3. So therefore this is a cubic graph. So a regular graph of degree 3 is called a cubic graph. So these are the different types of graphs that we have learned from this video lecture. There are even more different types of graphs depending upon the properties of those graphs. Like it could be a directed graph, undirected graph, cyclic graph, acyclic graph, finite graph, infinite graph, labeled graph, and then mixed graph, which will be both directed and undirected. And there are also some special graphs like Peterson graph, then path graph, cycle graph, star graph, wheel graph, and we have many more different types of graphs in graph theory, which we will explore in our further lectures. Hope you have understood this lecture. Thank you.